Welcome to Talks at Kirkland. I'd like to welcome Brian Deere. He's the author of the book, The Friendly Orange Glow, and the book was the first to tell the story of the PLATO System and its relation to the dawn of cyberculture. Before becoming an author, Mr. Deere was the founder and the chairman of Eventful Incorporated, the makers of Eventful.com, the world's largest event search engine. He was also the founding director of eBay Design Labs at eBay, and he's also been in management at Easel, MP3.com, Flatworks, Real Networks, and Coconut Computing. And he actually owns the domain coconut.com, I found out. So let's welcome Mr. Brian Deere. So thanks for coming.
Thanks.
So if this is the first historical work, I'm assuming that a lot of people don't even know what Plato is. So do you mind giving us an overview?
Sure, yeah. I mean, it is remarkable that it is so largely unknown. I mean, it was a pretty major government project. It was funded by the same agencies that funded ARPANET. Any takers, ARPANET? ARPA and NSF were the major backers of Plato. The PLATO stands for Programmed Logic for Automatic Teaching Operations, a real tongue twister. The project started in 1960 at the University of Illinois at Urbana-Champaign. And the idea was to, you have to understand that this was right after, let's see, it would have been 3 years, basically 2.5 years after Sputnik got launched by the Soviet Union. And that kind of freaked out the US government, and it freaked out the media, and it freaked out a lot of politicians, that the US was weak in science and math and engineering education, because clearly the Soviets beat us to launch a rocket into space. And so what were we going to do about this? And suddenly there was this massive flow of funding out of the Congress starting in 1958. At the same time, NASA was started and ARPA was started. And tons of funding started flowing into universities and companies to do something about improving what we would call STEM education today. And the University of Illinois had a lab that had been set up during the Korean War called the Coordinated Science Lab. Actually, at the time, it was called the Control Systems Lab. They renamed it Coordinated Science Lab, keeping the CSL so the U.S. government would have no trouble continuing to write checks, but they were trying to move away from being a military classified lab doing mainly research on radar systems and air traffic control, very similar to the radiation lab at MIT that some of you may have heard of from World War II. There's lots of books on the history of that. So anyway, Plato emerged with the idea, like, could we do a civilian project to apply a computer to be a teacher and instruct students who sit down in front of it on any academic subject? And it's pretty remarkable that they were doing this in 1960, only a few years after psychologist B.F. Skinner at Harvard was kicking around ideas with teaching machines. And the first chapter of my book is all about what he was up to and how his timing was really good, because when Sputnik arrived, suddenly everyone looked at teaching machines and what was called programmed instruction as maybe a new way to really help educate a lot more people, because there weren't enough teachers and that kind of thing. So Plato started as a pure educational project to turn a computer, which at the time was the ILiac, which is one of the big old vacuum tube, monoliths from the 50s, when there were only a handful of computers in the world. And it would fit in this room, but it was all vacuum, thousands of vacuum tubes that failed, in a week or something like that each. So we were constantly replacing it. But yeah, so that's what Plato originally was. What makes the story interesting is what it became later. And I argue it kind of became a precursor to much of what we take for granted today on the net. A lot before people realized was possible.
Right. Yeah. So my next question was about the first that Plato brought about. Reading through the first part of your book, you talk about a lot of technological first with the touch screens and the plasma displays and such, and then you move into social and human interaction
Right.
changes in the first, where you get into the cyberculture and the social networks and things that evolved. Maybe we'll start at the beginning with the technological changes and just what were some things that Plato was on the cutting edge and the defining edge of.
Well, it was way beyond, before cutting edge. It was like bleeding edge, rough, blunt edge. It was, they had to basically build and construct everything from scratch, both software and hardware. They had an ILiac box the size of this room. They didn't have any terminals. They didn't have any graphics. They didn't have any memory. They had no telecom capability, no networking. They had no software. Everything was machine code, really, really primitive, just maybe one notch up from zeros and ones, but it wasn't even assembly language. And that's what you programmed the ILiac in. And so that was where they started. And one of the things they realized right away was, if you're going to teach students, you need to have a graphical display. They understood that. They had been exposed to projects like SAGE, which was a gigantic military project that involved real graphical displays that had been built for billions of dollars. So the technology was known. It was just insanely expensive and not practical. And just to give you guys an idea of the cost compared to, we now have even one person holding a smartphone in this room has more memory than all computers combined in the world, probably until the 70s, I'm guessing. With a few gig, 16 gig, right? When Plato started, one idea was for the display, they would use video RAM and a CRT. And so they went off and bought they found a used $10 television set that the tuner was broken. But hey, it was a CRT and it worked, so that's all they needed. They didn't need the tuner. Then they were trying to figure out how to do memory. And RAM in 1960, 61, 62 was $2 per bit. So do the math on your 16 gig phone, right? Or 64 or 128 gig phone. We're talking a couple $100 million. So even then, to have a 512 by 512 pixel display, which is what the idea was, it was going to cost hundreds and hundreds of thousands of dollars. And just, for students in schools that, when teachers can't even afford chalk to put on the blackboard, it just was not going to, the economics weren't there. So they had to come up with something else. And what they came up with was an idea that actually had been kicked around for quite a while, it turned out, of using gaseous discharge, gas plasma discharge if you built an array of conductors, one going vertically, one going horizontally, and you ran electricity through any intersection of the conductors. In theory, you could basically light up one little cell that had neon gas or some other kind of gas in it. And the holy grail was, can you make that a gaseous cell have memory? Can it have, essentially, you could set it in such a state that it would stay lit. And if you could do that, then you basically have a memory cell, and it would be a lot cheaper than RAM and stuff like that. So they worked on that for years, and they tried everything they could do. They wound up with a breakthrough in 1964, and I talk about that in the book, where they finally build a single pixel display. That's all they had. They were using, if as a kid you remember, if you ever played with a microscope, and the little square pieces of glass that you put on top of a slide in a microscope, and then you look at some parameciums or something, those little tiny thin wafers of glass, they created a sandwich of them, and so there were 3 sheets of glass. The one inside had a little dot drilled through it, and that was the pixel. And they managed to get neon gas into it. And normally neon gas glows orange, just like a campfire. But some nitrogen from just normal air had leaked into the tube, and it glowed blue. But that was their breakthrough, and it actually if you send a certain amount of electricity through, a spike in the signal, and then you send a smaller sustaining voltage through, the pixel will stay lit. And that is literally a 1. And you can send then a drop in the voltage, and the pixel will go off, and that's 0. And but they had achieved memory in a display. So by 1972, they had 512 by 512 versions of these with orange pixels. And literally, when you're sitting down at one of these screens, you are viewing the memory. There is no RAM that it's refreshing constantly at like 60 hertz or something. You're looking at the memory. So it was a pretty ingenious invention. And they also realized, if we had 3 pixels per pixel and we used different color phosphors, we could have RGB and we could have color, And so they actually put that in the patent. So they invented plasma televisions. And it turned out to be a really lucrative patent that poured millions of dollars into University of Illinois and helped fund Plato for many, many years. Lots of companies, Fujitsu, IBM, NCR, all kinds of companies would license that patent, and plasma displays wound up in everything from checkout counters at the grocery store to airline ticket counters and banks, and nuclear submarines wanted flat panel displays because the CRTs took up too much room. So it wound up everywhere. So.
Okay. Awesome. And so the book's The Friendly Orange Glow. When did Plato switch over to the RGB display? Or did it ever?
No, because it was just too expensive.
Okay.
And in fact, really, there were prototypes. They had colored displays in the lab. I remember seeing one in the 80s. IBM built one. They built like a 1024 by 1024, I think it was, plasma color display. But it would have cost $100,000 or something, so it wasn't practical. It was only when Fujitsu came out with the 42-inch plasma vision, like in the mid-90s or something. That was the first plasma television that you could buy and hang on the wall. It would only set you back about 15 grand, though they became dirt cheap over time. But
Amazing. So technologically, it's like you said, bleeding edge. But then it started as a teaching system. And then you said it evolved to something else, more of a network system. So
right.
Let's talk a little bit about that.
They always had this dream of scaling the system up. It's kind of funny when you look back at projects. You hear about scale in any startup today, right? The whole dream is you build a product, you build a service, and you got to scale it up. And you throw it into the cloud, some cloud service, and you have virtual servers. And it's all, people nowadays don't realize how good they have it compared to what they were dealing with in Plato. One of the jokes in the Plato era, I heard this from people all the time when I interviewed them, was, every bit is sacred. And, when you were coding, a program on Plato, you might get, about 1,000 words of memory. And so you literally had to worry about allocating, and assigning real meaning to a single bit rather than, we'll just assign a long to a binary value or something. You did not have that luxury. It's kind of funny. I think Microsoft Word probably exceeded the entire cyber OS, all of Plato, all of its programs, all of its data, and everything in footprint in terms of data. Probably years ago. Any big app nowadays is kind of bloated compared to what the Plato people were facing. Everything was scarce, and every single aspect of the system, you really had to think carefully because there wasn't the luxury of resources we have now.
And you said cyber is the operating system that ran under Plato?
No, what happened was so Plato started with the ILiac computer, which was completely inadequate, and all the other professors and researchers on campus were also using that thing, which means you had to sign up for time. It wasn't a time-sharing system. So you might get 2 a.m. or something like that. And the way you programmed the ILiac is that you worked on paper for days or maybe even weeks beforehand, and your time on the ILiac was actually trying to compile that program, and it better work, because if it didn't, you would probably blown the hour that you had, and so you'd have to go back through the equivalent of core dumps, I guess, and try to figure out how to, where there was a bug. And then the next time, maybe a week later or something like that, you might get another 2 a.m. session to run it again. So it was insanely inadequate as a development environment. So CSL put out bids for a better computer, and IBM and Control Data both came in with with RFPs or whatever. Control Data came in with a $995,000 CDC 1604, which at the time was like a pretty fast machine. IBM came in with one of its big iron machines for about $1 million. When they saw that CDC was like $5 less, they said, okay, we'll sell it to you for $500,000. Control Data came back and told the university, ours is $995 firm. So IBM came back and said, we'll sell it to you for $250,000. And Control Data came back and said, no, ours is still $995,000. Long story short, the University of Illinois bought the Control Data machine for $995,000. IBM was furious, sued, and did all the typical stuff that companies do. Wound up in a huge battle in the state legislature. When all the dust settled, IBM went off very upset, and Control Data got the deal. And that kind of changed the whole history of PLATO from then on, because the first thing they did was build an ILiac emulator in the 1604. So they were back to running ILiac again, but it was all emulated and it was much faster. And they had time. And then they started annoying all the professors around campus yet again, because PLATO was starting to consume way too much of its time. And so in a couple of years, they got a second 1604 for $1. And that really sealed the fate of PLATO, because from then on, they basically had a relationship with Control Data. That was the architecture for the rest of time. And by the early 70s, they had always had this dream of scale to get up to thousands of simultaneous users. By then, CDC had a real supercomputer, the Cyber 6400, 6600 series, massive mainframes, very, very multi-million-dollar machines. And they bought one for PLATO, and that's what PLATO started running on around 71, 72. And that's when things got weird, because by then the lab had gotten much bigger. There was a huge influx of people, and this lab was very unusual. And I don't think I'm not aware of another lab in the 70s, a computer lab, that on a university campus in the United States that would have been similar to this. Every other one I've heard of, MIT, Stanford, whatever, they were pretty locked down places, and you had to have access to get in. And so they were limited, and you didn't have a bunch of kids coming from the local high schools wandering into the building. If you tried to do that, you'd probably get kicked out, and your parents would probably get called, that kind of thing. But at the University of Illinois, at the PLATO lab, they encouraged people to wander in, and there just happened to be a high school across the street. And sure enough, all the geeks from that school just wandered into PLATO, saw these incredibly amazing, 512 by 512 graphics displays that had built-in touchscreens on them, and people were doing amazing things with graphics, in 72 and 73. And they were not getting kicked out. In fact, they were encouraged to sit down and start programming. So a lot of them learned how to code, and starting around 1973, there was this amazing 12-month period where the whole PLATO system really completely changed in nature. It had been all about education. The kids, ironically, the recipients of the education that they were supposed to get out of PLATO, took one look at it and saw the development environment and realized, we could do other kinds of things with this, including, interterminal kinds of things, including interpersonal kinds of things. So chat rooms started up. There was an app called Talkomatic. Instant messaging fired up in December of 73. Email and what were called notes files, which are the equivalent of message boards and message forums, Usenet, and that kind of thing. All those things started. There was an online newspaper, and then there was a whole raft of nonstop games being built. And these were all multiplayer, multi-user games, MUDs and dungeon games. They were all graphical. And all this started by the teenagers from the high schools and in undergrads. It was never part of the National Science Foundation mission to, build all this recreational, social stuff. But, what struck me, and it only struck me after I finished writing the book, was that, if you look at this history that's laid out of this project, and you see what they built so early, you realize that I kind of describe it as the interpersonal computer revolution started before the personal computer revolution ever started. Before Apple was incorporated, before the Altair was out, I think, certainly before Microsoft was incorporated. I'll put it another way. While Larry and Sergey were still in diapers, PLATO was booming with this online culture that had all the kind of apps that got people addicted, and they were having the dopamine rush in 1973 that we hear talked about today with social networks, and Twitter and Facebook and Google Plus, it's just remarkable because there's no computer history book, there's no museum that has a timeline that shows that all this advanced stuff was going on really early. Then it kind of and it didn't really even die off. It just was a parallel universe almost that very strangely got ignored. And how many of you, show of hands, have ever heard of the book Hackers, Heroes of the Computer Revolution by Steve Levy? Good. Well, those who haven't, get it. It's worth it. It's a great book. It's a great story. It came out in 1984. It's still in print. I think O'Reilly has a print out now. It's what inspired me to do this book, because I always felt, the first thing I did when I bought that was I rushed to open the index and look under P for Plato. Nada. And that's been the way it's been ever since. Even Walt Isaacson's recent book, The Innovators, doesn't have a single mention of Plato in it, which is absolutely remarkable. But then on the one hand, I'm kind of frustrated and I want to rant at them for why didn't you, blah, blah, blah. But on the other hand, what resources did they have to even know about Plato? If you didn't know someone or if you didn't use it yourself, it really was a you had to be there kind of thing, which is really unfortunate. I mean, probably, I'm assuming none of us here were at Xerox PARC, but we probably mostly know about that history. It's been well documented. There's been great books about it, and it profoundly influenced the industry. The Lisa and the Macintosh and Windows and all that stuff. And there's been great books about that, but there's never been a book about Plato. So I always felt that it was desperately needed so that we can get Plato into the conversation and no longer live in a world that's kind of ignorant of it, because it's pretty remarkable. So
you have a passion for it and an interest in it, and there's no books about it, so you had to discover it somewhere. So how did you meet Plato, I guess?
I come from 5 generations of newspaper publishers and editors. My father's father, his father's father, his father's father, going back to 1850, they owned the Jersey City Journal, which was the second largest paper in the New York metro area. I think it's still around, but anyway. So I grew up in a household of 10 daily newspapers. My hands were always black from the ink. I loved reading newspapers. I was a Watergate junkie as a kid. So I entered the University of Delaware as a freshman in 1979 with the idea, I guess I'll be English/journalism and maybe, go work in a newspaper. That was the family business. And I was wandering around campus. Literally the first week I was there, I was walking through the music building, and there was a room that I just, how in a lot of university classrooms, there will be a door to the classroom entrance, but then there's a glass window, floor to ceiling, and you can kind of look in, right? Well, the lights were off in this room, but I saw that all these faces were in there, sitting down at terminals with their headphones on, and they were all like reaching out and touching the screen like that. And I'm looking at it, and there's very crisp, high-resolution graphics depiction of musical notation. And then there's a keyboard, like a piano keyboard at the bottom of the screen, and they're all like interacting. They're clearly listening to the music they're playing. And I was pretty impressed because, I mean, I thought, 70s computing was like scrolling ASCII, or VT100 if you're lucky, So I went in, and they didn't kick me out. I checked it out. There was a big poster on the wall saying, "Welcome to Plato." I had no idea what it was. And I found out real fast. I mean, I sat down, and within a few minutes, I hear there's, someone's cracking up laughing at another terminal. And, I wasn't used to the idea that people would laugh at something on a computer. And they were chatting with somebody. And then someone else was reading a hilarious message that someone had posted in one of the notes files. And then it dawned on me that they weren't all there learning. A lot of them were interacting with people on the other side of the screen, somewhere else on the campus, or I didn't know how far this extended. There were other people out there using terminals too. And then it dawned on me that University of Delaware was kind of like this remote island. It wasn't the cool place. The cool place was the University of Illinois, which was where Plato had started. And then I discovered that the Delaware PLATO system was connected, kind of like a poor man's internet. It had a dedicated link to a control data PLATO system in Minneapolis, which connected to Illinois. And then there were other systems around the world, in Canada and Europe, all the way down in South Africa. And most of them were interconnected, and you could send email to anybody. And that just kind of blew me away. Yeah, the degree in English/journalism lasted about a week, and then it was pretty much a degree in Plato since then. So
awesome. Yeah. And so at the time when you met Plato or first started using Plato, then it was already a worldwide network.
Yeah. Okay. I mean, I had nothing to do with building the system or anything. I was just a user.
Gotcha.
And I just couldn't believe that this thing was so cool. And what it also did was completely spoil me from the microcomputer revolution, which was raging at the time. Apple II was out, the Commodore PET had come out. I guess the TRS-80 or whatever it was called from Radio Shack, and then the IBM PC came out in '81. The Lisa came out a few years later, and then the Mac. And I looked at all this stuff, and it's like, why would anyone want to sit down at a lonely, disconnected, kind of toy computer? There's no people in that box. There's no way to chat and interconnect with them. There's nothing addictive about it. And yet they were all addicted to PCs. And I'm like, but look at this. This is Plato. It's much more interesting. This is the future. That's like, future people. The people is the killer app. I think Plato people understood that from day one. I arrived late on the scene. But I immediately picked up on it, and I saw that this was clearly going to be the future or our doom or both. And I think we can agree it's both. So oops. Now I just speaking of doom. So yeah.
No problem. And so where is Plato now? Like, is it still operable?
Well, it's like any of these vintage kinds of things. It's still running as an emulated environment on some Intel box somewhere. There is a website you can all go to, cyber1.org. That's CYBER, then the number 1.org. And a bunch of former Plato engineers have kept all the software around. They got permission from the University of Illinois to take the entire catalog of many thousands of hours of educational lessons and stuff, and the games, and all the famous games, which we probably ought to spend a moment about, because the games themselves are remarkable. So many of them are the precursors to things that would come later that would be hugely famous. And you name it, the type of game, the certain design aspects of games. The first graphical D&D games were clearly on Plato. There was a game called D&D that was out in like 75. Moria came out in around 75, 76, which I played all the time. It's still an incredible game. It's on Cyber One. Avatar came out, and I have a whole chapter about all the dungeon games called Into the Dungeon, which is, Avatar was remarkable because it was incredibly sophisticated. And what you started seeing, and this is also kind of interesting, in the startup world today, or the app culture, as it were, everybody has an idea, you go quickly develop an app for a smartphone, and you maybe get some VC money and, have your roll at the dice. Maybe you'll get lucky and get rich or whatever. So many apps today are built as reactions to, I would argue, similar apps that predate it, and that you have an idea for smarter, faster, better, or whatever your thing is that's, ER, that's going to improve upon what was built before. And I would argue Google is a reaction to InfoSeek, Lycos, and all the inadequate search engines of the 90s, right? PageRank was the big breakthrough. And Facebook is clearly a reaction to MySpace, which was a reaction to Friendster, and you just keep going back to, I guess, 6degrees.com or something, if anybody remembers that thing. But that's often the way it was. And the same thing was happening, that pattern was happening on Plato. Some kid would develop a game. The next weekend, some other kid would have said, oh, I have a better idea. We'll change this and that. And they'd come out with a game. And so it was kind of like the Billboard Top 40 of hit apps, as it were. Every week, or even every day, there'd be something new that was building upon and improving upon some previous game or whatever. And by the mid to late 70s, some of these high school kids were spending 4 years coding the game before they would release it. Avatar didn't release until about 79. They started working on it in like 75, 76, when they were 13 years old. And they wrote this entire operating system. In fact, they literally had operators who were to manage the data and all kinds of things that were going on behind the scenes to manage the game because it was so complicated. And that had been built upon all the designs and thinkings of all the games that came before it. And it was just remarkable. And then it would be years later we would start seeing the same pattern emerge with the web and with mobile apps today.
Awesome. And so I think actually we're going to open it up for questions from the audience too. If anybody has a question, please go over to the mic and ask away. Otherwise, I have some more. But yeah, please.
Thank you so much for the talk, and thank you so much for your time. My question is, so what you're suggesting is things like, let's say, AOL Instant Messenger, right, which made instant messaging ubiquitous, was basically available 30 years before that.
Right.
That to me suggests like a conspiracy somewhere that basically suppressed the ideas that came out of Plato, so that it's not recognized today as mainstream ideas.
Well,
so
yeah.
Is that true, or is it?
Well, a couple comments. One, if you've ever heard of the phrase patent troll, what's interesting about Plato is that it is the mother lode of prior art. So, in fact, I've a couple of times been retained by attorneys for gigantic companies, including Google, that were sued by trolls. I just realized, Google was one of the defendants in this giant, ridiculous case of some crazy patent that no one had ever built the thing, and they'd been selling it, and then somebody owned it, and they tried to troll all the big companies. And oftentimes the attorneys would go like, this is a job for Plato, because they knew that like somebody did it back, some kid did this very thing, in like 1973. And sure enough, in that one case I remember I was involved in, we were literally 2 days away. We were making all the arrangements to truck a vintage terminal, probably one of the ones at the Living Computer Museum here in town, down to East Marshall, Texas, or wherever that infamous courthouse is that does all the patent troll cases in the United States. Hi, Marshall. But apparently, when they heard that, I was going to give testimony and a demo of Plato, and that I had been this author of this book that was coming out, and that cost a settlement like that, So it was unfortunate because I was really looking forward to demoing Plato to a jury in Texas. It would have been cool, but yeah. So that happened a lot. So there's a lot of cases where there are predecessors on Plato for things that would become commercial later, and there are many cases of that. One of the things it's important to understand that when the community was doing all this stuff in the early, mid, late 70s, that was a time before there were software patents. There was no method patent or anything like that for software. You could patent hardware and physical things, but they hadn't yet. I can't remember what year the software patents kicked in, but so that mindset didn't really exist. And there was also, since this was all on a university campus, it was all an educational, not-for-profit kind of thing. So the motivation for all these kids that developed all these cool things was, fame and glory online. I mean, that was what they lived for, and they got it in droves. Some of these people were like literally net.celebrities before that term existed. And just to give you a sense of how strange it was that Plato, in a way, I sometimes liken it to the Galapagos. It was a protected ecosystem that developed on its own. Much of the rest of the world completely paid it zero attention, and so it didn't have any predators, as it were. And it was also, I guess you'd say, from a network perspective, a homogeneous network. They were just Plato terminals connected over the network. So they didn't have to worry about interoperability. One quick anecdote that again will shed light on how obscure Plato became. For years, I was poking around looking through the RFC documents, if you're familiar with them, the request for comments. There's thousands of them that formed the basis for all the specking that was done to build the internet. And RFC 600 was always missing from every single repository. And literally, as of the early 2000s, there were probably 50 RFC repositories on the line by then, and every single one was missing number 600. And by then, there were several thousand RFCs, and I could never find RFC 600. And the reason I was looking for it is because it had to do with Plato. And so someone finally said, "Oh, you need to talk to this guy who wrote it. He's in Santa Barbara somewhere. He's probably retired." So I tracked him down, and he had a nice big long chuckle, and he told me, "Yeah, the RFC 600 was a proposal to connect what they called an Illinois plasma terminal to the ARPANET." And so I asked the guy, "Why would you want to do that?" And he said, "To play the games," which I that was a perfect response. It was like, they were bored doing the stuff on the ARPANET that they could get access to, and they were probably telnetting and doing all the rest. But they heard word that all the cool stuff was on Plato. And unfortunately, the packet network architecture of ARPANET and Internet later was anathema to Plato's communications protocol, which was designed, again, every bit is sacred. The notion of a packet would be so wasteful, all that overhead, all those bits that are so, it could be used for data and they're just used for addressing. It's like, are you nuts? So again, it's, everything was designed for speed on Plato through 1200 bit per second serial or modem connections. And, so it was a very different thing. So, I think they got it somewhat working, but with packets and everything, it would be like one character, next character plotting of text. It was unusable. So,
do you have any theories on why some forward-thinking things like Plato never had much of an effect on the industry, while others, like as you mentioned, Xerox PARC, had a lot of influence?
Well, that's an interesting question because, in fact, a lot of the thinking on Plato did influence the industry and is still influencing the industry. There are Plato folks that worked at the University of Illinois as student programmers and stuff that are still working at Google. I know one guy is one of the, I don't know if he's a director level or high level manager working on the data centers and stuff like that and the build out of all that. So they're out there. I mean, I just saw a guy yesterday down in Silicon Valley who worked at Apple for like 20 years. And, you know, a whole bunch of people came out from Illinois and went to Apple. First they did Atari, then they moved to Apple, and they did their 20 years at Apple, which, when you think about it, you know, it must have been remarkable. You know, Steve, then no Steve, then Steve back. You know, that kind of history, right? But yeah, there are probably the most famous case of a technology that inspired something that became a multi-billion-dollar hit in the PC and internet world is Lotus Notes. Lotus Notes is named after PLATO Notes. PLATO Notes was written by a 17-year-old kid named Dave Woolley in 1973. He was literally one of those kids that wandered in from across the street from his local high school, and you know, they wouldn't go away. They wouldn't be turned away. And he just was so curious about the system. He learned how to program. And they said, well, we really need some kind of conferencing or message board system. You know, everything, people need to be communicating 24/7 asynchronously. Like, I don't know how to solve this problem. So, and it's 2 a.m. right now. Maybe someone can answer this tomorrow. Let me post a note somewhere. And so he went off and wrote PLATO Notes and shipped it in August of 1973. And it completely transformed everything on PLATO. It started the whole era of collaboration online with teams and everything. And then, of course, they realized, well, we don't have to just talk about work subjects. We could also talk about sports and music and movies and politics and all the rest. So sure enough, all that stuff started too. And, you know, all hell broke loose when that all started. And years later, well, actually in the 80s, when a couple of friends who had worked all as student programmers at the U of I, they went off to various companies, and they decided to form a startup company in 1984 called Iris Associates. And that was where Lotus Notes came from. That's Ray Ozzie, Tim Halverson, and Len Kaywell. Len lives right here in town somewhere. He has a little startup, I think, right in Kirkland, actually. But so they went off and did that, and they had funding and support from Lotus, which was famous for 1, 2, 3, but not forever, because Microsoft came out with Excel. Lotus needed something new. They went with Notes. They shipped it as a $64,000 product in about, I think it was 1988 or 89. It was a massive hit in enterprises. It wound up having about 110 million users. It was sold, basically it was the last big product that Lotus had, and Lotus was sold to IBM for about $3.5 billion in about 95, 96 because of Lotus Notes. And if you look at the feature set of Lotus Notes, you know, a lot of people would cringe today because we have open web and stuff, Google Docs and stuff like that, but they didn't have that back then. This was a stepping stone. Once again, a reaction to what had gone before. You know, they saw this great collaboration capability on PLATO, but now could we bring all that to a local area network environment in an enterprise? And that's exactly what Lotus Notes was. It had very many of the same features as had been on PLATO that had been written by the kids back. So a lot of technology made its way out. A lot of games did too. You know, there were a bunch of PLATO game authors that made the leap to Apple II and IBM PC, and some of them became multimillionaires. And in fact, I have a whole chapter on one guy with an incredible life story. I urge you to read it. This guy wrote probably the most beautiful game on PLATO called Mahjong, and it was the Chinese tile game, gorgeous graphics. And I interviewed him in 1997. And I had seen him online in the 80s when I was on PLATO. And I remembered he was very active and everything. And halfway during the interview, I asked him a question or whatever, and he mentioned, oh, by the way, I'm in a wheelchair and I'm a quadriplegic. And I programmed Mahjong with a mouth stick. That's literally the only input he had. And he had designed, I have a really, probably the best color photo in the book is the screenshot of Mahjong. It is staggering that he did that with a mouth stick. He wrote all the code. Then he bought a Macintosh in 1985, and he ported all of the game to, I guess, C language environment on the Mac, all the graphics and everything. Again, just using, input devices for disabled people, and an absolute miracle. Activision licensed it, published it, and they sold 10 million copies. And he now lives in Hawaii, and I went out and visited him a couple years ago, and it was just absolutely remarkable. He's doing great, and he's made a whole life for himself. And he tells me it was all because of Plato. Plato saved his life. He had a gymnastics accident at Stanford when he was an undergrad. He was on the varsity gym team, and he was in the gymnastics gymnasium and was in the middle of doing a flip or something in practice one day and landed in what was called the crash pit, which is foam stuff. There just wasn't enough foam, and he broke his neck. And he should have died right on the spot. And there's a whole cascade of coincidences and miracles that happened that day and in subsequent days. And I'll urge you to read the chapter to find out more. So how's that for a teaser?
Thank you again for being here today. The topic's of particular interest to me because I started college a year after you did, and the second programming job I ever had was writing courseware on a PLATO system.
Wow. Cool. I was wondering if anybody here, had been there and done that,
Yeah, I didn't do it for a long time, but I was wondering if you could elaborate a bit more. Somebody asked about, what happened to it, and you talked about how it still lives on like an emulator on an x86 now, but like what, from the, like I was working on it like 81, 82,
right,
something like that. Could you elaborate like what happened through the 80s? Did it just kind of die a slow death, or?
It was kind of similar to what happened to Digital Equipment Corporation. If you remember, they made VAXs. They were kind of important, and a lot of people used them. Now, DEC is this ancient history thing. Control Data Corporation was a major player in the computer industry, and they were based in Minneapolis, Bloomington area, and their whole history was they sold mainframes, they sold big iron, and that was their whole mindset. That was the whole sales force was oriented to selling, getting a customer to write a check for like $5-10 million per box. They used to have a saying, if you can plug it into the wall, it's too small. You needed literally a dedicated channel from the electric company to power one of their things. And so Plato, for a while, fit in that model. They could sell big mainframe systems with gazillions of terminals to go with it to universities, and they did that all over the world. There were Plato systems set up, University of Alberta, University of Quebec, probably, maybe a dozen or more in the United States at various universities like Delaware, all over the place. And so they really tried really hard to commercialize it. But their timing, once again, timing is either good or bad. And, in the era where the microcomputer is just raging, and it's like it's not only a freight train, it's a freight train carrying freight trains of the future at you, right? That was they were faced every single day. So, they might try to sell to a university or to a gigantic school district, and they'd say like, why should we spend $10 million on this system, and then another maybe $10 million on telecommunication costs, thanks to Ma Bell at the time. People didn't realize that the phone lines often were more expensive than the hardware, and I've already described how crazy expensive the hardware was. Phone lines were even worse than that, thousands per month and that kind of thing. Why should we buy all that stuff when there's like this Apple II that Apple's practically giving away? We could buy a whole room full of them and still afford chalk, for the classroom or whatever. So it became a real problem. So the company, Control Data, really struggled. Meanwhile, the University of Illinois, that was the home of Plato. That's where the lab was. They were entrepreneurial too, and they decided, we're going to have to part ways with CDC, and we're going to try to commercialize it ourselves. We tried with CDC. It doesn't look like it's going to go, and we still think we can do this. And so Don Bitzer, who was the founder and the leader of the Plato project, had a vision still, in the early 80s that he could get hundreds of thousands, maybe millions of terminals connected all over the world on a network of servers, essentially. I mean, what he was kind of envisioning was very similar to, what Google has or any major net company now with data centers all over the place, fail-safe, redundant hardware. If any server goes down, the user never even notices. It just flips to another server where all the data is still there and it's all instantaneous and everybody's happy. So they were thinking about those kind of things even in the 80s. And so Illinois spun off another project called Novanet, which was a commercial venture to commercialize Plato. And that actually did well. That actually did commercially well. And it survived until just a couple of years ago. In fact, the epilogue of the book is the final night when Novanet shuts down. And I reluctantly stayed up late that night waiting for this thing to shut down. And of course, whoever was supposed to shut it down at like 2 a.m. was late. So there were like 22 people, these diehard Plato folks, hanging around, chatting in the notes files and in term talk and stuff for a couple of hours, waiting just for the thing to shut down and issue the, Novanet will be shutting down in 60 seconds, ... Novanet will be shutting down in 30 seconds, ... 10 seconds, then, Novanet is gone. And that was it. By the early 2000s, I believe it was, Novanet had been acquired by a whole chain of companies, like one fish eating another fish, bigger fish ate that fish, and it was now owned by Pearson, the gigantic global conglomerate that ironically had gobbled up a bunch of Plato's competitors from the 80s and 90s as well. And but they had decided it was time to go web and use different technology and a different product line. So Novanet was finally, quietly shut down. But what's important to get back to your question is that, Novanet found a market, and it wasn't one that was sexy or cool and wasn't going to be written about in Wired. It was basically remedial education and the last chance for high school kids, for example, who were struggling and were going to be kicked out of school permanently because they just didn't have the learning skills or they had learning difficulties. One thing that was discovered early on Plato is that students who have those kind of difficulties do really well interacting with the computer because none of the social peer pressures of performing well in front of all these other kids in their class, none of that existed. You could have a one-on-one interaction with the computer teacher, and if you made a mistake and the screen said no, try again, you wouldn't get laughed at in the classroom. And they also discovered that Plato had a gigantic market in prison education. So in prisons all over the United States in the 70s and 80s, Plato was used to provide GED training and things like that, job training, so that some inmate could get out and get a job and have skills and even get a degree. And it turned out to be incredibly successful, and that was one of the markets that really worked, which was, who knew,
All right, well, so we're close to the end of the hour. A couple of things. There are, I think, only 2 of us in the room, and I'm not one of them, who have actually seen and used a PLATO system, but that can be different Saturday because at 1 o'clock at the Living Computer Museum, Brian is going to go and he's going to give a talk about his book, and then they're going to have a 2-hour session after. There are actually 2 running systems there. So I encourage anybody who's interested to go and take a look. And that's this Saturday. And also we have a few more books for sale with the Google subsidy. They're half price, so they're only $20. And yeah, Brian will stick around, I think, to sign them afterwards. And other than that, let's thank Brian for coming. Yeah.
Thank you.